this for the people that aren't here. All right, so this is the demonstration on how to do a restored cross section. So a restored cross section takes information from several rock columns and connects them together through correlation methods like we did in class to understand the overall geology of an area. So what we are looking at are rock columns that lie along the border of Pennsylvania and New York State. So we're going to be looking at 15 of them. You have 1 through 8, so this region of the border, on one sheet of paper. And then you have 9 through 15 on your other sheet of paper right there. So the first thing we're going to do is we're going to connect these 2 sheets of paper together. Now, I gave you 2 copies for just one purpose, and that is if you make a mistake on one set, you have a second set as a backup. If you don't make a mistake and you don't need to start over, that's scrap paper. All right, the first thing we're going to do is tape the papers together. And you want to tape them together so that, of course, they're going in numerical order, like this. And you also want to line up this dashed line. So you want don't tape the papers together like this. Don't line up the edge of the paper so it's neat. Don't do that. Line up the dashed line like that. Line up the dashed line. That means, yes, that the edge of your paper is going to be off like that. That's just the way it photocopied. And then a couple other things you want to do is you want the space between columns 8 and 9 to be similar to the space between the other columns. Okay, so make sure that that space is about the same. And also don't put any tape between these columns. You're going to write in there. So no tape. So you're going to put tape above, and you're going to put tape below. And then I'm going to put tape on the back just so it doesn't flop around. Okay, and that's all you need the tape for. You don't need the tape anymore. Now, anytime, any kind of tape will do. If you don't have Scotch tape, you can use masking tape. You could use duct tape. That'll work just as fine. Now, the scissors, what the scissors are for, if you choose to use them. Some students don't like that this doesn't line up, and they just want to cut that off. So that's what the scissors are for, cutting off the edges if you don't like that it's uneven. If you don't care, you could just leave it that way. It is perfectly fine. All right, any questions on how to tape the paper together? All right, the next thing we're going to do is we're going to take a look at the fossils that are in these rock columns and the materials. So the patterns that are used for these rocks are universal. There's that speckled pattern, that's sandstone. This is the dashed line pattern, that's shale. This is the block pattern, that's limestone. And there's another pattern on here that you don't see as often, and that's this pattern here, that's conglomerate. Conglomerate are pebbles and sand that are cemented together. So it's like sandstone, but there's pebbles in it, where sandstone just has smaller particles in it. All right, so that's what the patterns are. And you're going to be working with different colors. And I'm going to write them on my paper just so that I remember it. So you might want to do that too. I'm going to put sandstone. And I'm going to use orange for that. And then limestone, green. And if you don't remember what the patterns are, you might want to even mark that down too. Dots, limestone, bricks, shale is dashed lines. And the shale is brown. And then conglomerate is the purple. And those are the small circles. Okay, that if you don't remember the patterns, I'd write that down too. So there's all that, if you want to jot that on your paper. And then I'm going to sharpen my pencils while you do that. So, and I gave everybody a sharpener, and I gave everybody a ruler, and I don't need any of that stuff back. I paid for the sharpeners, you can keep them. I paid for the ruler, you can keep that. You'll use it in the future. The colored pencils were like stuff, I gathered them up out of a box that has been hanging around here for a couple years. They're all my random leftover pencils. You can keep those too. That doesn't bother me. Okay. All right. So I pointed out what the rock types are now. There's fossils on the paper too. The fossils are these little letters here. The A, B, D, E. These are index fossils. If you remember, I don't know what organisms they are. That's not really important for this particular lesson. But they're fossils of organisms that are useful for figuring out the age of rocks. They're fossils of organisms that lived a short period of time on Earth, and they also were very widespread. So they're good for matching up the ages of rocks in different locations. So there's several fossils. There's an A, B, C, D, E, F, and G. 1, 2, 3, 4, 5, 6, 7 index fossils were discovered in these rock columns. So remember the law of superposition, the youngest features on the bottom and the older, flip that. Oh my gosh. The older features on the bottom and the younger features on the top. So obviously, if you look at all these rock columns, A is at the bottom of each of the columns. So it's the oldest fossil. And A is found in all of the columns. Now over here, it's kind of interesting because A isn't all the way down here at the bottom, but A is the bottommost fossil. Now this column 15, only has A, B, and C, 3 of the fossils. So also some other things, there's wavy lines at the top of the columns. That would be the land. So there might have been more layers above that are gone due to erosion, weathering and erosion carried it away. Or maybe the layers that contain these younger fossils, E, F, G, which are missing over here. Those fossils are not here. Maybe there was never any layers that formed there with those fossils in it. That could have been land. When this region here was underwater, this region over here might have been land and they just never formed. Or this region over here experienced less weathering and erosion than this place over here, and it was all removed. So these rock columns, it doesn't really tell us what happened in the past, but by putting this together and looking at other data, geologists can kind of figure that out. All right, so what we want to do next is we want to identify what parts of the rock columns are the same age. And to do that, we're going to draw lines connecting the fossils. So the fossils, if you look up here in the sandstone, you see that dashed line? That represents the location of the fossil. And down here where the pattern is the shale pattern, that little dotted line is harder to see, but it's there. So what you're going to match up is you're going to take your ruler and you're going to connect the A's together. And you want nice straight lines. So I bought everybody a ruler. So please use that ruler and match up all the A's. You're going to go all the way across and match them all up. And you're going to do that for all the fossils. Match up all the A's, all the B's, all the C's, and etc. Okay? So go ahead and match up the fossils. And well, I will do the same on mine while you do the same on yours. So this work, what you're actually working with is actual material that was used by geologists when they first were trying to work out the geology of the eastern United States. So these methods that you will be doing in this activity will be very similar to the methods that those early geologists did. And you might think that it's kind of boring here geologically in the eastern United States, because we don't have active earthquakes and volcanoes and such. But as roadways were being put in and railroads were being put in like in the 1800s, it exposed these rock formations, and the eastern United States became a region where it was just geologists were just actively coming here to work, because there was so much being exposed rock-wise, and it was giving them opportunities to study geology like they have never had before. And as a result, this region became very well understood geologically. A good eraser is useful too when doing this work. A good eraser. So these materials, so hopefully you did the part 1 activity of this. That was a Google form that I had you do the other day. I guess it was Friday I signed it. My hope was that you got that done. That is the preview information to try and understand the work that you'll be doing in this activity. So in that particular activity, you looked at a restored cross-section along the Colorado River. All right, so I'm here doing my fossil D now, and I noticed that there's no fossil C in the first couple columns. So fossil C is missing. So that would clue scientists in to say, hey, why is fossil C missing? Well, either the organism didn't live there when the material was deposited, or the material was there and then it was removed by erosion. If that's the case, that could be a disconformity. That maybe there's a disconformity in columns 1, 2, and 3 because fossil C is missing. And as you're doing this, I hope you're taking notice too of what rock type it's moving to. So it sometimes the fossil stays in the same rock type, but that sometimes the fossil moves from one rock type to the next. So like I noticed between 9 and 10, fossil C is at the edge of the shale, but that shale is completely missing in fossil C, and the fossil just exists in the sandstone. So there's a change in rock type at that location. So where fossil C is represents material that was deposited at the same time. So on the right, I'm still doing fossil C. It's in conglomerate, so that's heavy stuff. Heavy stuff gets deposited close to shorelines, and lighter stuff gets carried further away from the shoreline, from land. All right, I'm doing my E now, so I'm almost done. Okay, and then I have F. There will be a few follow-up questions added to Google Classroom tomorrow. They will be questions that you would answer using your restored cross-section. All right, and I'm doing G now. And I am done with my fossils. All right, so let's see what we've got here. We have in columns 1 through 6, and you could include 7, there are more fossils there, index fossils, than from 8 through 15. There are less fossils. Also, as I was doing that, I noticed that these fossils, A, B, and D, were in shale, and they continue in shale. And then A and B and C continue in shale, but then they start disappearing from the shale, and then they're only in the sandstone and conglomerate. So in general, as I'm looking at this, I see bigger material over here. So this is like pebbles and sand, mainly over here. And then we've got finer material over here on this side, okay? I also notice if you trace along a fossil, so here we have fossil B, it's in conglomerate, and then it goes to sandstone, and then it goes to shale. You see that? So it's going from heavier material here, and then into smaller sand, and then into smaller shale, which is made of mud. So the beach, when this stuff was deposited at time period of fossil B, the beach was over here. It was over here. And that is where it was the whole time. It was over here to the side. So that's kind of interesting that the beach was over here, and this whole region was covered with water. So this was like a shallow ocean at that point where this was, and the beach was over here. So it might have been an island. It might have been the land might have been lower at that point, and the mountains might not have even existed at that point to make it covered, and there might have been some mountains over here. So that's one thing I noticed just from looking at that initially. All right, so we've got all of our fossils correlated. So now we're going to start correlating the rock types. So I'm going to start at the bottom because that makes sense. And I really don't have to look too closely at this right now. You got to be careful when you start matching up rock cell, because especially like here, you might be tempted to match this shale with this shale, but that's impossible because this part is older than this part, and I know that because of the fossil. See, this here is the same age, and this is the same age. So when I start matching up rock types, I want to make sure that I'm checking the fossils to make sure that they're not saying I should match a rock with a different section of the neighboring column. That's important. All right, so I'm going to take my ruler and I'm going to start here with at the bottom. There's some limestone. I'm going to go ahead and I'm going to draw some lines at the base of the limestone and then at the top of the limestone. This is why I was very particular about that other activity when I said you need lines at the bottom of the rock and at the top. This is why I was particular about that because it makes this activity so much better. You'll have nice, neat work. So you're matching up the limestone, and I'm going to go all the way across because it actually, this limestone, this would be the oldest material, this limestone. So I'm trying really hard to get this lined up right, but I'm seeing this at a different angle than I would normally. I would normally work right over top of this, and there's a camera where my eyes would normally be. So I might get a line out of placement a bit. So far, I don't think I'm doing too bad. I am planning to work the whole block with my little video. I'm just going to keep going. So when I get done in the block, will be in the video. But what will not be done in the video, you're on your own. After that, it's your interpretation. Now I'm looking here in column 12. Look, there's a little bit of sandstone right there. Okay. All right. So what I'm going to do is I'm going to draw my line at the bottom. And then at the top. Whoops, at the top. All right. So in the work that you guys did in preparation for this, the Google form, the Facies Relationship Lab, you learned about something called Walther's Law. So Walther's Law simply states that I'm gonna kind of paraphrase it, but if there's, in this case, limestone in column 10 and limestone in column 11, then you can I'd say that there's limestone in between them. Okay. Now, if there's limestone in column 11 and there's sandstone in column 12, there's a transition zone between the two. So I have to show a transition zone, and I'm just going to draw a little wedge like that right there. Somewhere between here is a transition between the limestone and the sandstone. Now, I can make it longer, I can make it shorter. If it's a very wide wedge, like this here, look how wide this conglomerate is. There's conglomerate here, but it's not there. So that wedge there is going to be, it's going to extend further, like that. All right, I got to show a transition zone between the conglomerate and the sandstone. So that's a big wedge. But this is a little skinny amount of sandstone, so I'm just drawing a little tiny wedge. All right, so then I'm going to draw my lines there, and I've got some sandstone there, and there's sandstone there. So I'm going to connect that together too. All right. And then let's get the rest of our limestone here. Hello. What brings you here?
We are going to scrub this floor out here.
Oh, that sounds fun. They're scrubbing, the custodial staff, guys, is scrubbing the floor outside my door. I'm glad you guys let me know. Because I'm clumsy.
Oh, well, we're starting down there at the outside doors.
Uh-huh.
We probably won't get up here anymore today.
Okay, so I won't like come out of my room and go flying on the floor.
No.
There's a camera right outside. That would be funny.
No, we probably won't get down here today. I'm gonna put this here just so I know I put it here.
All right, guys. So here at column 14 and 15, you can see I've got some limestone and I've got some sandstone and I've got some more limestone. All right, so I could go on and make more lines and do the shale that's above it, but I think I want to start coloring. And the reason I want to do that is I confuse easily. So I've got some limestone that I'm going to color, and I've got some sandstone I'm going to color. So my limestone is green. So I've got my green, and I'm going to color the column and between the column. And I'm choosing to do this way instead of all the lines because I will start to get confused between it's like between the fossil lines and my rock type lines. Now, if there happens to be anybody that's colorblind, if you need to substitute a shade that you might have on hand that will stand out better to you, go ahead. If you are severely colorblind and the colors are it's just too difficult, you may draw patterns. Just make sure that they're distinct patterns.
Actually, which color are you using right now?
I'm using green.
Thank you.
I'm using green on the limestone. All right, now over here is where I've got different colors coming in. Remember that little wedge? That has to be the color of my sandstone, and that's orange. So I'm going to do that first, or I will probably color right over it. So sandstone, just double check there. I'm going to color my orange because it's so tiny through there. I always like doing this activity. I also liked when the class did this activity because everybody seems so focused and And I kind of like it too, because you guys are, when doing this, of course, they're going to do this with computers now. But early, before computers, this is how the geologists did it. They would have drawn these diagrams and correlated all this. So you're kind of doing what they did to try and understand the geology of the East Coast, Pennsylvania, right here where we are. That's kind of neat. So limestone typically forms in deeper water environments. I find it interesting that there's limestone all across these columns. So this whole area at one time was the bottom of the ocean. And some limestones formed as a coral reef. Others formed, limestone forms lots of different ways. Tiny organisms that have shells. That stuff just kind of settles to the bottom of the ocean floor and accumulates over time to form limestone. All right, so that's my bottom layer. So the next thing I'm going to do is that shale above it. So I'm going to get my pencil back. And now I've already done the bottom line because that was my line for my limestone. So I just have to do my shale line. So some of you are probably good to go, and you're going to work and probably go faster than me. That's fine. Just make sure it stays neat. And it's very important if you choose, if you like are in your own little zone and you're not, I don't even know if I'll get to this area. This area here between columns 7 and 8, I think you should make a note to yourself. Be careful. This area, don't match that. You're going to match this. Follow the fossil. Follow the fossil. Okay? That's very important. That's where most of the mistakes are made, between 7 and 8, right there. And another place where students make errors is up here, because they don't notice this little tiny little piece right here. That's conglomerate. That gets matched there. That's another place I commonly see an error. Other errors I see is don't forget to make the little wedges right there. Don't forget to make the little wedges. All right, I'm just going to keep working. And you guys can do the same on your end. And if you have questions, just unmute and ask your question. And hopefully I didn't screw up the video. Sometimes I'm making videos and I forget I was making it and I never recorded it. And then I have to do the whole thing over again. Oh, look at this. I almost missed it. There's limestone in there. Did you guys see that? Column 6, there's a little tiny skinny limestone. You know what I think I'm going to do? I think, yeah, I'm erasing. A good eraser is important. I'm going to, that's a fossil. Let me put that line back in. There is a little skinny layer of limestone there. I am going to color that so that I don't forget it. That's another thing students miss, that little skinny layer of limestone. So I'm going to do that. I almost missed it. All right. It's right there. So color that. It's right there. I'm going to sharpen my pencil because the point's not sharpened. Interesting. So now the scientists would be looking at that and they'd be like, why in the world is that little skinny layer of limestone there? What happened to form that? It's just from here to here. Like, was there a die-off of sea creatures that kind of deposited all that calcium carbonate and formed that skinny limestone layer? Did the climate change dramatically and allow for a coral reef to develop, but then something happened to wipe it out? See, all these things they would identify. This would tell them that something happened. And then the next step is to try and figure out what happened. All right, and shale is brown. Shale often is brown. If you live in Newburgh, that's what color the shale is there. Limestone's typically gray.
That's brown, right?
Yes, that is brown. All right. Sandstone next. All right, so it looks like that fossil A is right at the border of the sandstone. So I really don't, I mean, I could color that. So this, at this point, it's like, okay, so what do I want to do? Because where do I want to work? So some students will just start here then and work, do each individual between each column. Or they'll do part of the sandstone, because the sandstone kind of, it gets kind of weird over here. You know what I think I'm going to do? I'm going to do this conglomerate next, is what I think I'm going to do. Because it's just going to make it easier for me to color my sandstone later. So I've already made this wedge when I demonstrated how to make the wedges. So I'm going to do the conglomerate. And here, the fossil goes from sandstone to conglomerate. But what I'm going to match up is the conglomerate. So when I color, this part is all going to be this color for sandstone, and above this line is going to be the color for conglomerate. And this line for this fossil doesn't impact what color I'm coloring it. So here, I have to put another wedge. There's sandstone there, but there's no sandstone there. So I'm going to make another wedge. Now, I don't know exactly where the boundary is going to be between this material. I don't know what shape it is. I'm just like, I'm making a hypothesis. So there's a couple ways where the scientists will figure out exactly where this boundary is. They can drill. They can do a core sample and take rock out of there, and that'll tell them where that boundary is. They can also use seismic vibrations to figure out where the boundary is as well. Now the top, you're just going to connect the top of the columns together. So this one, I think they just didn't include their pattern there. I think that's still conglomerate. So I'm just going to connect the tops of these together. So now the conglomerate gets thicker here. So there's a couple of reasons why it might get thicker there. It might have been thicker on the other places too, and erosion and weathering just kind of removed it. So it might have been there. Like this might have been thicker because the land would have been higher here. All right, so here we got sandstone at the top. We have no sandstone here, so we can't really match it together. So we're going to have to draw a wedge. And I don't, again, this is another one of the situations where I don't know how big it is. I don't know. Because the evidence is gone. I don't know what exactly it looked like there. So you just do your own interpretation there. And then I've got a little conglomerate here. I'm going to connect that. And then there's none over here. So I'm going to draw a little wedge again. Again, I don't know what shape it is. That's underground. All right. I think I'm ready to color my purple. Where's my purple pencil? I lost it. Don't know. Oh, it's on the floor. Okay. Got away. All right. So, start here. And don't color super dark that you can't see where your fossil marks were. You need to be able to see the fossils. So don't color so dark that you're completely covering up the fossils. So now conglomerate is deposited closest to the shore. That's the heavy stuff. So material comes off the land and then it's deposited as the energy of the water slows down. So the heavier stuff gets deposited first. And the lighter stuff gets carried further away from the beach into the deeper water. So this heavy stuff, the conglomerate, would have been near the beach. Keep track of time, got another class. I feel like I'm coloring too dark. I want to be able to see my fossils. I might have to go back. I might want to go back over it with a marker type thing so that my fossils stand out, or just go back over with my pencil so that it is this. I'm trying to color lightly with this colored pencil, but this one just seems too dark in general. Or maybe it's just because there's fossils in this area where the other ones didn't have it. Maybe that's it. So when you take, you're gonna take pictures to turn it in. So make sure that I can see your work. So that deals with actually taking the picture, but it also deals with me being able to see what you put on your paper. So if you see that there are things that, because of the color, are now harder to see, the picture, whether or not you take a good picture, might not be the reason why I can't see something. So you might have to go over some things to make sure I can see it. Okay? All right, so that's all the conglomerate. There isn't any more conglomerate. I'm done with my purple. All right, so now I think I'll go ahead and work on the sandstone because I felt like I needed to take care of this here because of my sandstone. Because I know this is sandstone through here. I might want to, before I color all the sandstone, I might want to, I mean, you can work wherever you want. I'm choosing to jump all over the place because that seems to work okay for me. So I'm going to do this so I can do my sandstone. That and then my sandstone. Is orange. Okay. So this is sandstone. Sandstone here. Sharpen my pencil again. What else do I want to do here? Sandstone wise. So now I might switch gears and work on a different area because I'm seeing there's shale here and there's sandstone intermixing there. I might want to go ahead and figure out where my wedges are. Or maybe I just want to start here and just go that way. Because this looks kind of messy. I think I'm going to have to think about it a little bit with a little detail. So I think I'm going to go back here and take a look at what's going on here. So this is all shale, and that's shale. So I can color that all brown. And the same here, this is all brown. But here I've got some sandstone. I've got to draw some of those wedges. So I think I need to like match this stuff up. So Walther's law says that there's sandstone here and there's sandstone here. So there's going to be sandstone in between. So I'm going to go ahead and mark that. And then Walther's law says if there's one type of rock in a column and then in the adjacent column it's missing, there's a transition zone in here. So I've got to draw that transition zone. So that's a little wedge. Okay, so there's a wedge of sandstone. I'm going to go ahead and there's another little section of sandstone up here. So I have to do the same thing. And it just so happens that fossil line just kind of follows the border of the sandstone, but I need another wedge here. And I don't know exactly where these are. Just like I said before, we don't know exactly where they are, but I have to identify that I know that there's one there. And then there's a little skinny piece of shale there. So I might actually want to color that first. So I think I'm going to take my brown, color the shale. And it's a real skinny area, so I'm going to sharpen my pencil, my brown one. And that, oh, I just broke that. All right, I'll sharpen it again. I'm using pencils out of that same box where I gathered yours. All right, let's try this one. There's brown. Brown. It's so skinny, I just feel like that's what I need to do right now. Do that. It is one of those little wedges. I need a little tiny wedge there. I don't know if that did anything, but okay. All right, so now I'm going to go ahead and color this orange right there. I am going to have to end here shortly and clear out my work area here. I'm doing like demos in every single class. And the next one is earth science, and we're doing mineral identification. So I'm going to have to close down this video and switch my stuff around. So before I do that, are there any questions? Because I will not see you in a Zoom until after break, unless of course you want to come into my my office hours tomorrow from 10 to 11 if you have a question or you just want to say hello. All right, guys, I think that's all I'm going to demo right now. And I hope you guys have a good holiday. Let me switch my camera here. There. There. Now you can see me. All right, guys. I hope you have a good holiday, and I'll see you after the first of the year. Boy, I look horrible today. What happened to me? All right, guys. I guess that's it for today. Bye-bye.
Hey, do you want us to keep working on it?
Yeah, you can. Yeah, that's what you're doing tomorrow. You're working on that. Okay?
All right. Have a good day.
All right, you too. Bye-bye.